Good day, everyone. My name is Nikeshnan, and today I'll be explaining about our fluid mechanics lab 3. It is under control volume, and the title of this experiment that we're doing is impact of a jet. So let's get into it. Now, a bit of an introduction towards the experiment we're doing. So I'll read it out. A moving fluid in natural or artificial systems may exert a force on an object in contact with it. And to analyze the fluid motion, a finite region of the fluid, also known as control volume, is usually selected, and the gross effect of the flow, such as the force or the torque of an object, is determined by calculating the net mass rate that flows into and out of the control volume. These forces can be determined by the use of Newton's second law or by the momentum equation. So what is the objective for this experiment? The first objective is to investigate the reaction forces produced by the change in momentum of a fluid flow when a jet of water strikes a flat plate or a curved surface. The second objective is to compare the result from the experiment to the computed forces by applying the momentum equation. Now, the methodology of the experiment. On the left, you can see the apparatus that we'll be using. And methodology is that the momentum force is determined by measuring the forces produced by a jet of water impinging on a solid surface or a curved surface, which then deflects the jet at a different angle. The jet apparatus is a clear acrylic cylinder, a nozzle, and a flow deflector. Water enters vertically from the top of the cylinder through a nozzle striking a target mounted on a system and leaves through the outlet holes in the base of the cylinder. As air vents at the top of the cylinder maintain the atmospheric pressure inside the cylinder, a weight pen is mounted at the top of the system to allow the force of the striking water to be counterbalanced by the applied masses. Now, there are a few procedures or steps that we have to go through in order to perform this experiment. So the first step is to ensure the apparatus is first level and the lever brought in the balanced position, as indicated by the tally. With the jockey weight at its 0 setting, record the weight of the jockey, the diameter of the nozzle, the height of the vane above the tip of the nozzle when the lever is balanced, and distance from the pivot of the lever to the center of the vane. The second step is water is then admitted through the vent supply valve, and the flow rate is then increased to the maximum. The force on the vane displaces the lever, which then restores to its balanced position by sliding the jockey weight along the lever. The mass flow rate is then determined by collecting water for a specific period of time. The third step is to place the jockey weight exactly at the desired position and adjust the flow control valve to bring the lever to the balanced position. The condition of balance is thereby found without touching the lever. The range of the setting of the jockey position may be divided neatly into equal steps. And finally, the experiment will be run on two surfaces, which is the first one is a flat surface and the next one being a curved surface. So these are the results based on the experiment performed. The first table shows the results from the flat surface obtained from the flat surface, and the second table shows the result obtained from a curved surface. And based on the tables, a graph has been plotted. And when we analyze the graph, we can see that based on the graph, the force produced on each of the vanes is proportional to the momentum flow in the jet as it strikes the vane. For a flat plate, the slope of the graph is 0.97, with its ideal value being 1.00. So there's a reason it hasn't reached the ideal value, and that's because of a few errors that may have occurred. The main error being a systematic error, where the discrepancy when measuring the value is nozzle, where the error is performed, the error is caused because the measuring value of the nozzle diameter is not accurate. For the hemispherical cup or a curved surface, the slope of the graph is 1.92, where f equals 1.92j, and the maximum possible value for this is 2j, which occurs when the jet is deflected through 180 degrees without energy loss. So the ratio between measured force and the theoretical maximum may be regarded as efficiency of the vane, 0.96 in this case, and it will be less than 1.00 because of losses when occur during practice. And finally, the conclusion. Based on this whole experiment, the force on the vane is linear to the rate of the delivery of momentum. Experimental value and theoretical value are different because of systematic error. However, the errors did not affect the theoretical value of the experiment. This proves that the force exerted by a jet of fluid on a flat or a curved surface can be resolved by applying the momentum equation. That is all. Thank you for listening.